So I'm thinking to make a new folder. So I will just put all of the files that I just downloaded. I will move it to the folder that I use here. This is the data mining, and then I will make a new folder. Let me make a new folder notebook. And I will put all those files. This file is the IPYNB. And this is another file IPYNB, and there's one data set. I call this data set is housing.csv. If you use the Anaconda, you can use the Anaconda Navigator to run your Jupyter notebook, or if you want to run the Jupyter Lab, that's also fine. Maybe some of you may not be familiar with the command prompt, then you can use this one. You can use the Jupyter Lab, or you can use the Jupyter Notebook. Let's say I want to use the Jupyter Lab, then you can just click launch here, and then it will open the environment of the Jupyter Lab. Okay, so we use all this one. So I'm using the data mining folder, and I have the notebook folder, and you can see the files that I downloaded before. So if you already run, for example, this is using the Jupyter Lab, then you can just open the IPYNB. IPYNB, it means the Jupyter notebook. Okay, NB means the notebook. The IPY means the IPython. IPython is the previous version of the Jupyter notebook. Yes, and you will see the Python code here. Okay, I need to download the CSV file for the assignment, which is the churn modeling and the customer data. Go to the assignment. So I will download those two files, and I will put those two files into the folder that I have the Jupyter Lab. So this is the folder that I use the Jupyter Lab, which is the folder notebook. And then the data for the assignment, as you know, we have the churn modeling 01, and then we have the customer data. So I put those data in the same folder. For the second file, this is the Python ML basic. I will use the housing dataset. So let me get back to this. Okay, so if you are correctly open your Jupyter notebook, then you will see these three files. It's up to you where you want to put the files. Okay. Let me just use this folder to put all the data files, and I just put those two files here. For the modeling part, mostly we will use these two kind of libraries. We will use pandas and we will use NumPy. So we will use pandas, which is the library for the data analysis. and we will use NumPy. This is for the numerical Python. And then I'm going to read the files. So we use the pandas. We use the pandas to read the CSV. So we will read the CSV, which is churn modeling, and we will put it into the variable churn, and we will have also another variable, which is customer, to put the customer data. So we have two data, which is churn and customer, and let's see only the 5 early data. So 5 early data means the head. So we want to see 1, 2, 3, 4, 5. I think you already know this file before. We can see that the data consists of several attributes like row number, customer ID, credit score, geography, tenure, balance, number of products, as credit card, is active member, estimated salary, and accident. And we know that this accident is the target. Yeah. When we did the assignment, we have this variable. One indicates the customer exit. The customer will not continue to be a customer. And 0, the customer is still a customer. So we can see the profile of the customer. What is the profile of the customer that exit, and what is the profile of the customer that remains as a customer? And there's another file, we call it customer. This is the detail of the customer. We know that the customer ID, this one, his name is Hargrave and his age is 42. Oh, sorry, she is female. So we can see the 5 rows data like this one. Yeah, because we don't have much time to learn many things, so I will just focus how to solve the problems on the assignment. As you know, in the assignment, we need to merge the two data. We need to join the churn and the customer. So we can use the function merge. We are going to merge the churn and the customer. And we know that the left, which is the churn, it will be depending on the customer ID. And we know that on the right, we will depend on the customer identification. So they have two different attributes for the merging. Then we need to define what is the criteria to merge the two parts. So in this case, we are going to use customer ID for the left, which is churn, and we are going to use customer identification, which is from the right, that is customer. Okay, so the customer, we have the customer identification. So if you look at this data, because we are combining the data, we are merging the data, the attribute customer identification still exists. So if you go here, you will see the customer identification column, and you see also the customer ID. Basically, they are the same. So we don't need to use those two in the row. And we can do the merging by using the same command, churn customer, left on customer ID and right on customer identification. And then let's just drop drop means we will delete the column. So axis 1 means we want to identify that the column will be deleted. And if you have the new data, then you can see the head. Head means the 5 early data, and there is no customer identification. So the customer identification column has been deleted. And yeah, we can use this data for our analysis. For this example, I would like to teach you something new. Okay? Maybe if you join the class of the data structure or you join other class about Python. So I'm going to introduce you one of the library. We call it Pandas Profiling. So you can install this. I'm not sure if you have this Pandas Profiling in your computer, but it will be good if you install it. When you install any libraries in the Jupyter Notebook, or if you use like Visual Studio Code, or if you use any other environment, you need to put this nothing to, okay, the exclamatory sign in order to make the Python understand that you're going to install this library. Okay, if you do not have the libraries, then yeah, it will take some time to install the components. So some components might exist, like the SciPy, Pandas, Seaborn. Okay, if everything is fine, then yeah, you can start with the profiling. So this profiling, you need to import the Pandas profiling, and I'm going to use pp to indicate any function in the Pandas profiling. And then I would like to make a profile report from the data that I already merged before. Actually, I also want to show you another tools which is also good. This tool is called the SweetWiz. It is another visualization. So these packages can give you a new way of EDA. Yeah, the idea is the same with the profiling. So it gives you a very good exploratory data analysis based on every of the feature or based on every of the column. So let's say now I'm looking at the row number. So the row number is not meaningful. So let's see. And then we can see the customer ID. Customer ID is also not meaningful. So let's see the credit score. So when you move your mouse, then it will automatically change the graphic. And yeah, you can see all the details, like the distribution, and what is the most frequent values, and what is the smallest value, and what is the largest values. And then if you want to check the geography, then you will see all the details, like how many from France, how many from Germany, and how many from Spain, and etc. So this EDA tools is very powerful and very useful, I think. So next is when you try to solve the problems with Jupyter Notebook, or if you later on you use the Jupyter Notebook to do your team project, and you need to define some kind of group by functions, especially if you want to look at some properties in your data. Let's say I want to know how many people who exit from particular countries. So in this case, in the problems, we want to know how many people who exit from France. Then we can make some kind of group by function. You can count, and the exited, which is 1. From France, there are 810. So you need to show with the group by function. I think if you use Orange, it is much easier. You can just drag and drop, and then you can see all the result. But in this Python, you need to think how you can make the code, what kind of attributes that you want to consider for the group by, and then what is the function that you want to use, whether you want to use count, you want to use sum, or you want to use min, and etc. The other problem that you have in your assignment is how you can check the gender. Maybe I can download this assignment. Okay, so how many customers did exit from France? So yeah, you can answer by using the group by. And how many customers who exit were male? So yeah, you can also use the group by function to check the exit customer based on the gender. And then, do you think the exit customer join many products from the bank? So we can assume that the word many means more than one product. So you can also make the group by, and then you can use this function to check. Okay, the exhibit 1, the number of products 1, there are 1,400 something. So if it is more than 1, then it is the combination of 2, 3, and 4. And the summation of the 2, 3, and 4 does not more than the number of product 1. So the number of product 1 is the highest, so the answer is no. So I think you can see now you in your assignment section, your assignment score. Okay. If you did not give any good answer like this one, I give some deduction point in your assignment. So you can check your assignment. Let me know if you have any questions about the assignment. And how many exit customers who have credit card? So the customers who have credit card, yeah, you can also gain the group by based on the exited, and then we want to check based on the attribute as credit card. So the number of first exited customers who have credit card is 1,434. So the problem number 8 is the most complicated things. So let me just give you the code how to solve the problem number 8 with Python. The first is how to create column with the category. So in Orange, we can just use the simple if. We can deal with the feature constructor, and then you can define if the age is less than or equal 30, then it is young. If it is between 30 and 60, it is adult, and if it is higher than 60, then it is senior. So you can do this one. In this case, I'm just using the cut. So cut means I want to cut the numerical data. The numerical data here is the data with the attribute hits. The data with the attribute hits. Now I'm using a particular splitting point. This is the splitting point that I use based on the problem. We have 0 until 30. Yeah, we know that 0 is the minimum because there will be no h lower than 0. And then the next will be 0 and 30 until 60. And then the last one will be higher than 60. So we can just define the minimum is 0. So the class will be 0 until 30, and it will be indicated as young. And then the next will be 30 and until 60, it will be indicated as adult. And the last class will be 60 until 100. So we know that maybe the maximum is, it can be more than 100, but I will just define the maximum is 100 in this case. And I will use senior to indicate the person who are more than 60 until 100. And you can get this one. If you want to look at your, so in this case, use the widget distribution and show the ratio of young, adult, and senior. So if you want, yeah, you can use the sweet list. Okay, so you can analyze the data again with this one, and then yeah, later you can see the distribution because we just created a new column. Let's see this one. Let me make another one. So let me check the category. Okay, and you can see that adult distribution is the highest, which is 7,568. And then young is 1,968, and then senior, there are only 464. The next problem is we want to use discretization. So you learn about the discretize. We can have the equal frequency, or we can also have the equal bit. In this case, we need to use the equal frequency, and the number of interval is 3. In the Python, there is a function, we call it the qcut. The Q means the quartile cut. And we can use the equal frequency with this Q equals to 3 because we are going to make the interval equals to 3. And let's just define the precision 0 in this case. Then, yeah, the equal frequency here means that they want to check the interval in between 17 under 34 and 34 under 41 and 41 until 92. Okay, so the highest is 92 years old. Again, if you want to check the distribution, is the result the same as problem 8? If it is different, it then difference. So you again, you can use this analysis. Let me just use all the analysis. Oh, sorry, I didn't put this. I didn't put this into the. So you can look at the distribution in the category. The adult is the highest, but the QC, which is the new one, which is on the equal frequency. Yeah, they are now in the equal frequency. Okay. And for the next problem, we can do the normalization. So the normalization 0 and 1 with the attribute estimated salary and show the distribution with the pin width 0.2. I think in Python, you need to use a function. The function is from the sklearn, and you need to use one function which is min-max scalar. Min-max scalar means the function to use the min-max normalization. If you still remember, in our PowerPoint, we learned about the min-max normalization. And in Python, they have the min-max scalar. And once we use the min-max scalar, we need to fit the data, which is the estimated salary, into the new one. And this new column, the estimated salary, will be a result of the transformation. So this data is 0.5, 0.56. It is the result of the transformation. Maybe before that one, yeah, the estimated salary is very high, like 100,000 something. So we can use this to change the estimated salary from the real number into a number between 0 and 1. And show the distribution with the pin width 0.2. So if you are using the ORIX, it is easy because you can just use the drag and drop and then change the distribution width. But in the Python, I just give you one way how we can see the distribution with the pin width 0.2. So we will use the plot. In this case, I'm using the matplotlib. And then the histogram will be used. I'm going to plot the estimated salary. And then I need to see the rates of the data. What is the minimum of the data? And then I would like to know also what is the maximum of the data. And I would like to make the pin for every 0.2. So the steps will be 0.2, and you will see like this plot. So the step will be every 0.2, 0 until 0.2, 0.2 until 0.4, 0.4 until 0.6, and so on. And yeah, the distribution is quite similar. So since there are some limitations in the computer spec, we need to downsize the data from 10,000 to 5,000. So what is the best method? Please explain. In the assignment, many students just give the explanation, but you didn't do with the orange. So I also give deduction if you don't do it with the orange to change this data from 10,000 to 5,000. In the orange, you can see the function sampler, data sampler. So we can easily do the sampling. In Python, yeah, I give you one function. This is a function. How we want to do the sampling. So I'm going to use the group by function. So in this case, I would like to apply the, if you still remember, yeah, many of you answer the correct one. We can use the stratify sampling. What is stratify sampling? Stratify sampling. If we are using extended, then we want to check the same distribution. If we use the we use the 10,000 data, the distribution should be the same with the 5,000 data. What does it mean by the distribution? So it means the percentage of 0 and 1. If the percentage of 0 and 1 in 10,000 data is, for example, 40% and 60%, then when you reduce to 5,000, the percentage should be also the same, which is 40 and 60%. So if the percentage is the same, then we use the stratified sampling. If you don't use stratified sampling, the percentage might be different. Maybe this one can be 20, this one can be 80. So if it is not in the same distribution, then it will make your analysis bad. That's why when we do the sampling, yeah, we need to understand what kind of sampling method that we need to use in order to make the data analysis is good. Okay, so this is the function. Okay, so we need to group by the exceeded, and then let's make the group key equal to false, and then I would like to apply the sample. The sample that I want to use is 50%. So the frac means fraction. Frac here is the fraction. Fraction means the percentage that you want to reduce the data. If you want to reduce 50%, then you can just use 0.5. If you want to reduce 40%, then yeah, you can just use 0.4. Okay, so this is how to solve the assignment problem with Python. Okay. I hope that you can learn by yourself for the remaining things. If you have the data set for your team project, yeah, you can try also with Python if you want, or if you want to use the orange, that's also fine for you. So you can choose which tools you want to use for the team project. Please choose the best tool for you. Please choose the most convenient tool for you. But of course, every tool have limitation. If you use Orange, maybe it is simple, but it will not be so detailed like Python. If you use Python, maybe you are not familiar with the syntax, but you can define the detailed parameter. So it's up to you. Okay. And the second thing that I want to discuss is the how we can use the Python with the learning algorithms. In this case, I will just give you the basic regression. I think last week we already did with the orange. We have one data set, and at the time we learned about the auto MPG, if you still remember. And the auto MPG data set, it has the MPG, means the miles per gallon. We want to predict if we have the car properties, then we know what is the miles per gallon of that car. Whether the horsepower, or whether the cylinder, or whether the other aspect of the cars affect the miles per gallon. So here I will just give you a very simple way to do with Python. I guess some of you are doing very good in Python, but let me just give you very simple, so the students who are not familiar with Python can follow this Python flow. We can use several algorithms for the regression. I think in this case, I'm just using the linear regression, ridge regression, and lasso regression. And I'm going to use the housing data set. If you look at the housing data set, this is the housing data set. We have the price. This is the price of the house. And then we have another information like the lot size. Maybe this is the size of with the land something. And then how many bedrooms are available, how many bathrooms, and how many stories, okay, how many levels, and then is it in the driveway or not, and whether is it a recommended roof or not, whether it is full base or not. Maybe in Korea you have like full option. Whether they have the gas or not, whether they have the air conditioner or not, and then whether they have the garage, so the garage capacity, whether it is 1 or 0 and so on, and what is the preference area, whether it is a good preference or not. So based on this data, we can make the regression. The regression is, we know that the target is numerical data. So I'm using the data, which is housing.csv. Okay, let me just delete this one. So let me just use housing. And then for the simple linear regression, I will just use the price as the y, and then I will just use the lot size as the x. So we need to change the format into array with this way, and then I just split the data into training and the testing, and then I can do the model. So if you look at this one, if you are familiar with the Python, then it will not be so difficult to understand with the linear regression. So we will fit the training data and the y-train data, and then we are going to plot it into this one. This is the price and the size. Oh, okay. Due to the time, maybe I will explain the remaining on Thursday.